All right, let's go. So yeah, thank you for having me at Heriot-Watt University on this physics theory coffee workshop. It's a great pleasure to speak with you, but also for Christy to reconnect with me, because I've been teaching at Imperial College for 10 years now. I started as a teaching assistant, as a PhD student, and over time it's been really great to get back in touch with people I taught and hear that it's impacted anything. It's great to see what people do when they go off into the wider world, and how the kind of things I teach, as history and other subjects, informs and augments and improves even sometimes the scientific education and medical studies. And so what I've decided to do here is to do a presentation largely on physics, but also history at the same time, and you'll see what I mean. So we could also call it the past, present, and future of physics. And I'm going to be using a few case studies here for 20, 30 minutes to hopefully broaden your thoughts about physics, although I know they'll be really broad already, but just to inform you of the kind of things that people have already been discussing and how they can inform what we're going to talk about now and in the future. So my job, so when I taught Christy, I was a lecturer in history. And over the past 4 years, it would be, I got promoted and now run the Humanities Social Science program. So now I'm exposed to every discipline every day, both within science, engineering, medicine, and humanities and social sciences. And it's a great pleasure. And also for the last year, I joined the Data Science Institute at Imperial College to try and work on aspects of historical evidence. You might call it big data, big history. This is the kind of terms that come up. And it's a great pleasure to work on those, just getting started with that, really. And I'm also going to ask you about the reproducibility crisis, which is something we're looking at there. So my current focus is not just on my job, which is sort of teaching and program management, but when I have time to really work on some original things, part of my role, I am very keen to demonstrate the value of interdisciplinary research.
One day.
Can someone take their microphone off, please? I'm very keen to demonstrate their interdisciplinary value in research and teaching, of doing different things at the same time, or getting different people with different specialisms onto the same project. And that can often actually be the most productive way of doing it. I've got an MSc and a PhD in the history of science and technology, and I'm always keen to demonstrate the value of historical research data and evidence to any debate about anything, basically. And if you look at me on LinkedIn, social media, my michaelweatherburn.com, I'm endlessly producing what I think are interesting reports. I did one recently on Unilever and its attempts to forecast the future. And I then found the historical data from the 1980s with another former student of mine who was also a physicist. And we found that the 1960s projections for the 1980s were wrong, but in fascinating ways that help us inform futures thinking. So that's an example of using historical evidence to improve our thinking about the present and the future. I'm also keen, I'm very alert to the fact, as you'll see in this presentation, that a lot of academic endeavor gets kind of sucked into the academic world and doesn't necessarily get out into the world much. And so I'm very keen, when possible, to have what we call generally impact, right? Both on kind of big structured organizations in terms of policy and strategy. And I do consultancy work with governments in various ways, science policy, administration, and defense usually, to use historical evidence to inform decision-making there. But also the project I'm just about to start in Imperial College is a longitudinal study, that is a historical study, going back, finding our alumni. Christy doesn't even know this yet, which is why it was really interesting. He emailed me, finding our alumni and asking them what was the value that all their humanities, social science education brought to their studies, their lives, their careers. And as part of the preliminary phases of that, we realized physicists in particular seem particularly open and particularly able to use arts, humanities, social sciences work in their physics work. And that is something I'd love to hear more from you about, if you think that's even true. So what I thought I could do is just firstly, I give a lot of presentations to scientists who think they don't need history. And actually the first thing I would say, especially physicists, is you are sometimes the biggest historians of all. Especially if you're working on astronomy or something like this, because really pre-human time, but especially pre-Earth time, all history is physics, right? To know the origins of the universe and so on. So, we really need those special deep historians to contribute to our understanding of the massive arc of time. And then moving into later phases that we start to call it history, prehistory archaeologists, and then largely the word history gets applied to literate societies. That's maybe the last 6,000 to 10,000 years of human history. But I really think we just need to point out that the vast array of specialisms we all contribute together to understanding where we've come from and where we might want to go in the future. So I've got a couple of debates in mind from physics that I could tell you about, but I've picked one in particular, and if you want to know others, I'll highlight them as we go through and I can tell you more. But I thought this is one of these obscure books that, as Christy was saying, everyone kind of has heard of it, but it's been very hard to get hold of until recently, for reasons I'll explain. And what it says is absolutely fascinating, and I think you're going to love it. So let's have a go at that. So one of the things that history can do for physicists is let you know about fascinating developments that have already happened within physics and debates surrounding it. So this is Christopher Caldwell, not his real name. Real name Christopher St. John Sprigg, very famous in the 1960s, but not really during his life. He was a committed member of the Communist Party in Britain, and wrote very famous books, again, after his life largely, on poetry, politics, and what he called studies of a dying culture. And he really thought history was at a crucial crunch point where existing systems were totally breaking down and then new ones would be formed in the future. Unfortunately, he was killed very young, fighting in the Spanish Civil War with the International Brigade against Franco's troops. And he had largely written work he never realized would be published. It was found and then published after he passed away, including the book I'm about to talk through. Now, this is a crisis in physics. I must admit, I revisited this yesterday to give this talk, and it's a hard book to read. It needs editing. You can tell the author sadly passed away during its writing process, I think. So I've kind of distilled out the complexity from 1930s Marxism just to inform you some of the aspects of this, which I think are just genuinely very interesting, and also fit into my mission of combining science and humanities a bit more than we currently do. The book argues that we basically cannot separate science out from historical development or ruptures in anything else like politics, economics, and technology. And says, until now, just as living under capitalism has given us a sense of economic freedom, but it isn't freedom, it's just slavery to capitalism. We actually have a slavery to Newtonian mechanics, a very rigid model of physics. And the bit I would actually need to understand better from you is how relativity fits under the umbrella of Newtonian mechanics here. He's quite acerbic in attacking Einstein in particular for arguing that Newtonianism to relativity is a historical break at all. He argues that Einstein is just a continuity of Newtonian mechanicality, which he sees as very similar to the kind of rigid control by capitalism up to date. He also argues, and this is the bit that is not well known about this book because it's read by scientists, he also argues that under capitalism, we know there's a division of labor. He always uses the factory, as 1930s authors always did, as a metaphor for saying there's been a division in intellectual work, a false division between sciences and the arts. Linking all these points together, notes there has been a kind of world crisis in capitalism, and in the 1930s, it's a very persuasive argument, says it has led to a crisis both of science and in the arts, and between the sciences and the arts as well. So he sees this as a kind of very, very bleak moment to be existing, but also where a really new world could be forming out of the breakdown of the old. And you could be forming not just a new economic model, as the Soviet Union was trying to do at the time, generally not as successfully as we thought at the time retrospectively, but also a new model of science, a new model of physics in particular, and a new model of the arts in relation to science. And using just the language of the time, only in a Marxist future context can science and the arts fully inform one another and break free from, quote, the iron bourgeois determinism. And that's a Stalinist language if I've ever seen it. It's really very striking when you read these old books, the kind of language people would never use now. Maybe you will, maybe you will, having heard this, I don't know. But anyway, so that's a pretty grandiose theory written in a bit of a jumbled way that's hard to read. It's 200 pages long, but I can send a link round. Someone's kindly uploaded it to archive.org, probably Google, and you can read that in full. It's very, very thick thesis. So I thought that's a historical argument that can get us to think about present. Here's something we are dealing with at the present, which is the concept of big science. Now, I probably taught Christy this several years ago, but it's, if you don't know what this is, you do need to know what this is. And every year I teach at least 50, if not 100 scientists about this, and most have never heard of it. And there's just a cartoon saying, you know, the university is being accused of being bureaucratic. How should we respond to this? Set up many committees, policy groups, scoping papers, and in effect, more bureaucracy. And this actually, it highlights a very old sociological thesis by a guy called Max Weber, who's a German sociologist, called the iron cage of bureaucracy, that once you're in a bureaucracy, it's very, very, very hard to get out of it or to break it down and to form a smaller organization. But that's not, as I'll argue, necessarily a bad thing. There are many opinions on big science. So let's have a look at its history. This was a term coined in 1961 by, lo and behold, a nuclear physicist, Alvin Weinberg, there he is on the right, an American who worked on nuclear projects in World War II and afterwards. And this, of course, was when the Apollo program, the space, not just space exploration, the moon exploration was in particular being under development in the United States. So it suddenly gained huge cachet and still has huge cachet to this day. And when Weinberg formed this thesis, it was primarily about huge nationalist public sector projects, right? That, as I say, though, the definitions get very hazy because you've got to have private contractors, you've got to have international staff in a nationalist project, that like the Apollo, like the Manhattan Project, the nuclear weapons. How does that work? So he was very tight and controlling on definitions. And when you read interviews with him 20, 30 years later, he only passed away 15 years ago. He was dismayed that his term had been expanded to include so many things. He thought it had been devalued. I disagree, actually. I think maybe his definitions were a bit too rigid, but his concept is very important. The historical emergence of very big scientific organizations that behave in a certain way, perhaps including universities. So as I say, now big science includes all manner of national projects, international projects, civilian projects, like CERN, for example, is probably one of the primary big science case studies, even though it wouldn't fit into the original definition because it's not generally a military project, if you think about it. It's also too international compared to, say, the Apollo program. But the term has mutated and expanded over time. As I say, its original author didn't like that, but I've got no problem with it. I think it is really important we bring in this kind of management thinking into science and see what it does to science. And is science distinctive? Does it have to be managed distinctively? I'd love to hear about that. And also a debate I had in my classes this year, is COVID-19 vaccine big science? If it is, then the definition has changed a lot over the last 50, 60 years. And I would say at least 80 to 90% of my students all said, yes, COVID-19 vaccine is big science. So it shows the relevance of this today. So let's look at some of the critiques of this. Well, generally, I mean, this is not just sort of activist academics. This is, managers and policymakers also have issues with big science. You can subject big science to any of the critiques of bureaucracy that have existed over the last 100 years or more. They're hierarchical, they're opaque, and so on. And Hannah Arendt's wonderful phrase, in a fully developed bureaucracy, there is no one left with whom one can argue. Or as I put it, in a bureaucracy, no one is in charge. And sometimes being in a big organization, it can feel a little bit like this. But also there are benefits, as I'll point out. Another thing that managers complain about is, and scientists who've gone on to management positions, is big science is very secretive, especially anything that involves military application, but also commercial intellectual property, which has its own element of secrecy. Many of us think of science, and I think physicists in particular, as a very internationalist, cooperative exercise that should involve basically everyone, because you're all trying to discover the same essence of the universe. If you've got a secretive big science projects, does that not defeat the exercise in having a scientific endeavor? Another thing, we all have to consider cost. Now, I'm a manager, I do that a lot. If you have a big scientific structure, your science and your teaching gets more expensive because you have to pay lots of administrators. And some universities calculate the overhead at 50% of the total cost. So that's, you calculate what the science costs, and then you double it to add on the administrative overhead. And if you ever get funding in the future, you will find perhaps your employer, university, private sector, whatever, that take that slice and you didn't realize they were going to. So just ask the question, if you ever get any funding on the go, is when is the admin overhead taken out with this? Because you may not realize you get less money than you think. And the other one, which I've never managed to find any proper research into, but the fear is that big bureaucratic organizations cannot retain talented, especially young people who want to join exciting startups, like in the movie The Social Network about Mark Zuckerberg and the launch of Facebook. I personally think the small, tiny sector is very romanticized, and we don't really hear enough about its what it fails at and the working conditions, but that's a discussion for later. Activist objections, these are the fun ones. From the political right, big science has led, it has led to the decline of individual genius and related innovation. This is the kind of narrative that would say, you know, Isaac Newton was on his own when the apple fell on his head and he discovered gravity, some phrase like this, and he became a national hero. And without, you know, autonomy, scientists will not have these eureka moments. Like literally the original eureka moment, of course, as well, would fall into this category. And if you're just subsumed in paperwork and bureaucracy and regulation, you'll never invent like really era-defining things. And this can even be linked to national decline. You know, the decline of the kind of scientific stock of a nation might be declining because scientists are too bureaucratized. And that's typically a kind of conservative argument. Then from the political left, you find the complaints that, again, you find that science sometimes seems to spend a lot of time publishing papers and going to conferences, but does it really change the world out there very much? Not sure. That's why I'm interested in the impact agenda. It can, especially if you're purposeful in doing it, but kind of waiting for it to happen is, I'm afraid, it doesn't tend to get out there. But some scientists are fine with just their peers studying their work, and indeed promotions usually encourage us to be quite focused in the academy. An old but great argument from a great book I could talk you through is Stephen and Hilary Rose's book, Science and Society, who were young scientists like yourselves in the late 1960s, almost identical position to what Christy is in now as a PhD student. And they tracked through where was all this money coming from to pay for I think it was biochemistry PhDs. And they discovered it was basically coming from military funding and going into various military projects, just as their peers in the United States were discovering that the new chemicals were going into the Vietnam War. And it's one thing if you're told this, it's another thing if you don't even know, you're just told it's like public expenditure or something. So they had a real issue with this and then changed direction and went on to be life advocates for science communication, science activism, and aspects of transparency. And they huge bibliography, the two Roses. They're a wonderful couple. They present most things together. They're absolutely, what's the word, symbiotic. It's lovely to see them presenting. If you ever get a chance, do so. And the one which probably will resonate with some of you, and I kind of want it to, because this argument is underplayed in the scientific literature, even that which analyzes models of science, is J.D. Bernal's famous book, Social Function of Science, 1939, also, like the Caldwell one, it says, well, we need to, under big scientific institutions, we need to consider scientists as a labor force. And he was quite keen on organizing, sort of unionizing scientists. Also a member of the Communist Party, by the way, so his angle is quite predictable, but it gets forgotten. That book is largely thought of as prompting kind of research councils. A version that people remember certain bits of books, and they remember the research council bit, and they remember that Bernal was a communist who spoke very positively of the Soviet Union and its focus on science, especially physics. But people forget his critiques of science as a workplace. This has been picked up again. It's in a book, but I don't hear many people talk about this as much as I think they could. Steve Shapin's wonderful book, that I've put in the bibliography, talking of scientists as kind of lab rats. Okay, I mean, he's at Harvard University. He's a fantastically inspiring individual in real life as well. Do have a look at that. But I just, science as a workplace is something I think even within big science studies gets forgotten, and I wish it would get more prominent, because I think it's getting more important. In defense of big science, and this is where I wasn't going to add this, and I thought I ought to. Some science is literally impossible without loads of people doing it, or without like one person and a ton of automation. But even then, you still need, I have a version of this in which I just look up statistics of construction workers and things. I mean, to build CERN, you can't do it on your own, basically. Literally, to build the buildings, you can't do it on your own. So I think this idea that we can ever kind of ratchet down science and make it small again and somehow better may be impossible if you want to do certain kinds of science. Again, with the employment thing, if you can get a job in academia, which I'm well aware is not always easy, the employment conditions are okay, and they're probably better than being in a small startup, right? Again, I would love to see a better comparison between the two, and maybe I'll develop it over time. Number 3, the issue of secrecy. Some large organizations are actually pretty transparent. Compared to this, I don't know what's going on in this tiny startup sector. Most people don't. They don't know what's going on in the next room, to be honest. So the issue of secrecy, I think, can be overdone. And the other thing I'd like to point out is large institutions are good at remembering what they've already done. I'm concerned about how much science R&D is being done in the small tech sector that we will never remember, basically, because it has no bureaucratic process to maintain its memory into the future or to disseminate what it's doing. So you might just find yourself cycling over the same thing over and over and over again and have no way of even knowing this. So let's finish on something that I'd love your opinion on in particular. You may or may not know about the replication or reproducibility crisis, but in a survey from a few years ago here in Nature, as you can see, what's that? 90% of the 1,500 scientists interviewed said there's either a significant crisis or a slight crisis of reproducibility in science. And I've been teaching this year, and I was surprised to discover that not one of my students, all of whom are scientists, engineers, or medics, had heard of the reproducibility or replication crisis. None, right? And I think that's interesting, and it's my job to fill in these gaps, right? So it goes as follows. There are variations of this depending on which science you're a specialist in, but I've summarized. Many scientific endeavors are based on specific experiments, often very famous inventors, usually Protestant Western men, who worked long hours, and all these behaviors we canonize. And according to the rules of scientific method, if we can recreate the experiment perfectly, the results will come out exactly the same, right? And they don't, right? People have been recreating axiomatic experiments. This started in psychology. People trying to, the idea is you discover the essence of humanity through psychology, and they can't reproduce the original experiments, which we supposedly have discovered the kind of bedrock of human psychology. And even when they, as I say, even when they do recreate them, they produce different results. Then we get into the element of scientific publications, and we find there's actually an incentive, and quite a strong incentive in publications to not publish failures, right? Most publications in science should be publications of failed experiments, because the idea everything's successful, that's not how you learn science, right? That's a philosophy of science question that Christy and I and you can all talk about, as to how does science progress. But generally speaking, you've got to make a lot of failures in order to achieve some successes, and you don't tend to publish failed experiments, and that's a shame. But then even within that, if you do have an experiment and it hasn't gone that well, there is a demonstrable bias now for people to cut out the failed data and to produce a positive discovery out of something that was not a positive discovery. And this, of course, people justify it in terms of, I need the papers for a promotion, everyone else is doing it, and so on. I mean, at worst, that would constitute fraud, At best, it constitutes a system in need of some reform, shall we say. But again, it is, well, I can't reproduce the experiments because people are giving me a subdivision of the data, not the whole data set. And the one number 6, which I have not found any papers on, I'm working on this. You can see a video actually I linked in the PowerPoint there. I think I've done some interviews with heads of research at universities, and they say the other problem with the replication crisis, which may be affecting physics actually more than you might think, is we have ways of storing data. The data are degrading. We keep upgrading our software systems and they delete the old systems. The flexibility in employment, especially at the early stages of scientific careers, means people leave partway through projects. They might leave with the data set or how to interpret the data set or something. You find that the project memory is not just breaking down across, say, 20-year life cycle, but within 3-year projects, you find you get to the end and you don't have the institutional memory to really complete your project properly. And for me, that's a couple of years is quite a chronic problem if that's really there. I've just heard anecdotal evidence of that, but I need to do it. That's a project for me to work on in the future. And so that the real crisis, if you can call it that, is if we cannot do any of this stuff properly, is science actually science? Because any definitions of scientific method would indicate that you have to do differently from this. And if we want to have a discussion about this, I've just put specifically about physics in relation to the replication crisis. I hope you appreciate I've given you customized material here today because I'm so excited. Current literature asserts, like real scientific literature, that physics is generally immune from the replication crisis, afflicting other sciences, especially life sciences, and particularly psychology. And others go further, there's some papers there, and say that, well, because physics is basically almost bulletproof in terms of this replication issue, other scientists ought to be mimicking how physicists behave and work and research and teach, because it would help them solve the replication crisis in their own specialisms. And I'd love to know what you think. And I'll circulate the slides after this. There's all the readings I've cited. I really hope you read them. I would love to talk about Bernal and the Rose and Rose books more now if you want. I mean, these are sort of young activists at the time, really interesting things to say in addition to the Cordwell book. And that brings me to the end of my formal presentation. I hope you found that interesting and you can go off and look into it some more. Do stay in touch and I look forward to the discussion. Thank you very much.